Hello, my name is Drew Hogan. I am a computer engineering major at Utah State University, and today I'm going to be talking about a personal project I've done using an STM32 microcontroller. So, taking a closer look at this car, we have our microcontroller, two stepper motors, two ultrasonic sensors, a keypad for user input, and a portable charger. So, the final I did in this microcontrollers class had the user enter a series of commands such as 3 feet forward, 6 feet backwards, 15 feet left, 6 feet right, and so on until the user enters the pound button, by which the car would follow the given commands. Now, the user needs to first enter either mode 0 or mode 1. Mode 1 will do everything I just mentioned, and mode 0 will tell the car to follow a wall using these two ultrasonic sensors. So talking over some software now, after initialization, the microcontroller will wait for the user to input mode 0 or 1. If the user entered mode 0, we will call this follow left wall function, which is what I want to talk about today. If the user entered mode 1, then it will wait for the user to enter a series of commands and follow some other logic, which I go over in another video if you're interested. So the stepper motors that I'm using work by energizing different coils in this pattern. I'm energizing two at once so we can produce max torque. And you have to go through this loop 512 times for the axle to rotate once. Now, the main logic I want to go over right now is these series of for loops. Now we have this skip left Boolean along with this skip right Boolean that tell us if we want to skip energizing one of the wheels, meaning if this rotation we don't want to rotate the motor. Now, if you think about it, if you just if our car was too far away from the wall and we just stopped moving the left wheel, it would merely pivot, and the ultrasonic sensor would be out of our 15-degree range pretty quick. So we have these skip right and skip left integers that can keep track of if we just barely skipped that motor rotation, or if it's been a while. It turns out that after every 3 motor rotations, we want to skip one of the wheels if we're too close or too far away from the wall. And this allows us to turn and stay within a reasonable distance of the wall. So to illustrate that software, we have the car placed next to this rough circle, and it's doing its best to stay within 14 to 16 centimeters of the cardboard circle. So how these ultrasonic sensors work is they send out a sound wave and they receive it, the echo, and depending on how long it takes, that'll tell you the distance. So if these sensors are at too much of an angle, the sound wave will hit and it will bounce in a different direction and will never return. So if the sound wave doesn't return after a certain amount of time, my software will return a -1, which I can distinguish as an error. And we'll talk about how that is useful here. So looking at our follow wall left function again, we enter, most of this function is comprised of this while one loop, which we will never leave. So once we enter this loop, we're just going to continue the loop. And I've already gone over how we follow the wall using these sets of loops and this logic to check if we're too close or too far away from the wall. But some other logic I want to go over is if the distance to our left becomes more than 35 centimeters, it looks like our wall's opened up and we need to make a left-hand turn. So we're going to drive 10 inches, and I know this is not ideal. I'm using centimeters and inches, but I wanted to reuse a function from my final project. So this is definitely something I'd change if I redid this. But we're going to drive 10 inches, we're going to turn left, and what became useful is to check our front distance again, because we may have turned left incorrectly. So if the wall is there for whatever reason, once we turn 90 degrees to the left, then we will not drive 8 inches. If it is still not there. If it's more than 20 centimeters away, then we'll drive forward 8 inches and then begin to follow the wall that's on our left now. Jumping to this logic here, if a wall comes up on us in the front, we need to turn right. And if it's less than 10 centimeters, for whatever reason, if the wall snuck up on us, then we need to back up a bit to give us room to turn. And the last bit of logic I want to go over is right here. So we have this global variable, air distance reading, which is equal to -1. That's what these sonic distance functions return if they're unable to get an echo back. So if we're reading in air on the left, then we check again. If we're still reading in air, then we call this recenter function. And I'll come down here to that function. What we do here essentially is we are going to turn 1 degree to the right, check, and we're going to keep doing that until either we've turned by a sufficient number of degrees or we have in fact are reading a value. And if that worked, then we're going to turn a little bit more so that we are a little bit more in that 15-degree range. And if it didn't work, we're just going to turn back and we're going to try the other direction. And I got a video I'm going to show that will illustrate these points. As you can see, I begin by pressing 0 to let the car know I want to follow the wall, and then press pound when I'm ready to begin. For whatever reason here, the car couldn't sense the wall to its left, so after it had turned left, it checked the wall in front of it, saw that it was there, turned 90 degrees, checked again, turned another 90 degrees. We should be able to see a couple of examples of that, as well as the recenter function, which we'll be able to see after the car makes the next right-hand turn. Yep, right there you could see it stop and turn to the right a little bit until it was able to get a reading on that left-hand ultrasonic sensor. All of the code is on GitHub at the given website if you're interested in looking at it. After this turn right here, you'll see the recenter function be used again. Yep, right there, it turns itself to the right, and you'll see the car continue to follow the wall despite it becoming a little bit farther away here and there. So in conclusion, a few improvements that could be made to this car. As I mentioned, these sensors have about a 15-degree range, so having another sensor that points at about 45 degrees could be useful, so that when this car is at the right angle where neither sensor can display its distance, it won't be as lost. Other than that, the car seems to function pretty well and serves its purpose, so thank you for watching.